All righty. Hopefully y'all survived the snowstorm last week and are finding these videos to be helpful when it comes to homework. I have quite a bit of questions laid out. We'll go through as many as I can to help you prepare for the homework. Remember, if there's anything you need more help on, just let me know. I can make more videos, post some examples, or answer any emails or discussions y'all might have. Today, we're going to be working on lesson 3.3. Talking about quadratic functions. First problem I want to go over is on number 1. And again, all of this will be in the textbook. I'm just pulling questions that are pretty similar to your homework as well, at least as many as I can. In this first part, it's asking us to graph identify the vertices, or really and truly the vertex, because each one has one, and x-intercepts, if any. What we can do, the best way to approach this is to find the vertex and x-intercept, and then use those points to help you graph. Sometimes you can also find y-intercepts if you need more points, but it's not asking you to do that. It's just if you have no x-intercepts, you need some more points, and I'll talk about symmetry as well. All right, here we go, though. So the very first question says f of x equals x minus 2 squared plus 3. One big takeaway here is you need to know that the parent functions of quadratics are typically in the form of a parentheses x minus h squared plus k, where the vertex is just going to be h comma k. So what we can do here is notice this is a minus sign. So when you're dealing with the h, you always want the opposite sign of what you see. So since this is already there as a minus 2, then your vertex for this one would just be 2, because that's what the h would be replacing. So rule of thumb, just change the sign of what's in the parentheses. That is your vertex. And then your 3 there is your k. So therefore, your vertex is just 2 comma 3. Then it says identify x-intercepts, if any. Best way to do this is for x-intercepts, we know to be true that y is equal to 0. Well, y is the same thing as f of x. So what we can do is set this part equal to 0. And now we're ready to solve this. So I'm going to subtract 3 first. So I get negative 3 equals x minus 2 squared. And then to get rid of a square, I'm going to take the square root of this. And then don't forget that plus or minus, but I have a square root of a negative. Now, typically, that does give us an imaginary answer. But if you're looking for actual x-intercepts on a coordinate plane, they will not show up as imaginary. You'd have to go to a complex plane. So in this case, when you end up with a square root of a negative, there will be no x-intercepts because there's no real answers. There's only imaginary. So when this happens and you're trying to graph, you don't have to do this, but I would say let's go find y-intercepts, which we know to be x equals 0 as a true statement. So therefore, this would just be 0 minus 2 squared plus 3. That would just give me negative 2 squared plus 3. Anything squared is always going to be positive. So if you're calculator dependent, just know that negative 2 squared will give you a positive 4. If you forget the parentheses, the calculator will say negative 4, which is incorrect. Plus 3, which will give you 7. So therefore, at least I have another coordinate of 0 comma 7. And so with that, when I do a rough sketch of a graph here, I'll graph my vertex. So 2 comma 3. And I'll go ahead and sketch my y-intercept as well. 4, 5, 6, 7. And then what's nice about this is quadratics are symmetrical. So if I go back 2 spaces and then up 1, 2, 3, 4, I can go forward 2 spaces and up 4 to make it symmetrical. So if I go 2 to the left and up 4, I can go 2 to the right and up 4 as well. And that would be an exact nether point, giving you a symmetrical quadratic. The program will probably build it in naturally, but when you're showing your work, don't forget those arrows to indicate that your graph is infinitely going in 2 directions. All right, so pretty much just a whole bunch of these types. So I'll just keep going with that. We'll get into some word problems, analyzing graphs, but it's pretty much this process. All right, so the next one would be number 12. Same process, graph, identify the vertices, a vertex, and the x-intercept. In this example, we're given p of x is equal to negative x squared plus 2x minus 5. When it's in this form, best practice is to use a formula that will be a lot easier than trying to complete the square. If you try to complete the square to get it into vertex form, that is definitely a way, and I would definitely accept that. But seeing that we are in pre-cal, kind of I'm hoping that y'all just know the formulas. All right, so here we go. So to find your x, so in this format, your vertex is going to be negative b divided by 2a. And then your y would be whatever that answer is. And there's your vertex. If you don't know this already, this is your a, this is your b, this is your c. So if you want to come over here and say a is equal to -1, b is equal to 2, and c is equal to -5 to organize your information, that is definitely a good process there. But let's start off by trying to find our x. So this will be -2 over 2 times -1. So that's just -2 over -2, which is just 1. Once you have that value, now I'm going to go try to find what p of 1 is. So that's going to be -1 squared. Notice the negatives on the outside because I didn't replace the negative. I just replaced the x. Plus 2 times 1 minus 5. So that will give me -1 plus 2 minus 5. That would give me 1 minus 5, which is -4. So therefore, our vertex is 1 comma -4. So that's the best way to go about this one. When looking for x-intercepts, again, we know y is equal to 0. So I'm going to set this equal to 0. And now we're going to factor. You can factor by any method. You can factor. You can use the quadratic formula. You could use completing the square. Factoring doesn't always work, but it's my usual go-to. But quadratic formula, in my opinion, works all the time. And if you forgot the quadratic formula, it is negative b plus or minus the square root b squared minus 4ac, all divided by 2a. So I'm going to try to factor first, and I don't like dealing with negatives, so I'm actually going to multiply the entire equation by -1. So that gives me 0 equals x squared minus 2 plus 5. And I can kind of look at this and go, all right, I'm trying to multiply to 5, but add to -2. Well, there's only one way to multiply to 5, and that's 1 and 5 or -1 and -5, which is no way to add to -2. So then we are forced to use the quadratic formula. All right, so what I'm going to do is, again, use my original a, b, and c. So this is just going to be a -2 plus or minus square root of 2 squared minus 4 times -1 times -5 divided by 2 times -1. So I get -2 plus or minus 4. That'll give me 4. Positive 4 times -5 will give me a -20 divided by -2. And you could probably stop here because hopefully you're now noticing that 4 minus 20 equals negative 16, which will give you an imaginary answer. So there are no x-intercepts in this situation. So then I'm going to try to find the y-intercept, which again will be where x equals 0. So that means it would be negative 0 squared plus 2 times 0 minus 5. You'll see all those cancel out, and you're left with negative 5. Another thing to know as well, when it's in this form, which is called standard form, the y-intercept is also known as 0 comma whatever your c is. So if you want to quickly do that rather than having to plug in, you could do that way as well. So then when I come over here to try to graph it, start with the vertex that is 1, negative 4. Plot the point there. And then my y-intercept is 0, negative 5. 1, 2, 3, 4, 5. And so if I go left 1, down 1, I can go right 1, down 1 as well to keep it, because all quadratics are symmetrical. All right, let's do another one. So this one is number 15. So you're given q of x is equal to x plus 10, x minus 2 plus 36. All right, so when it's in this form, you're going to have to distribute this out and then combine like terms, at least get it in standard form and then go from there. Again, you could work that standard form back in using completing the square and go into the vector form. But again, it's a lot easier once you just remember how to find the vertex with the formulas. All right, so I'm going to distribute. So x times x is x squared. X times negative 2 is negative 2x. 10 times x is 10x. 10 times negative 2 is negative 20 plus 36. Combine like terms, so I get x squared plus 8x plus 16. Again, from this point, I try to, I'm getting ahead of myself, sorry. Vertex would be x equals negative b divided by 2a. I will always write the formula just for y'all, but you don't always have to write the formula. And again, if I label this is my A, B, C. So A would equal 1, B would equal 8, and my C would equal 16. So this would be negative 8 divided by 2 times 1, which is just negative 8 divided by 2, which is negative 4. So then I would figure out what Q of negative 4 is, which in this case, you can plug it in here or plug it in here. I don't think it really matters. I think I'm just going to default to the first one. Just it looks like the math would be a little bit quicker until I do it. It's probably about the same amount of math. All right, so negative 4 plus 10 is 6. Negative 6 plus 36. 6 times negative 6 is negative 36 plus 36 is 0. So my vertex would be negative 4 comma 0. And if I plugged it in here, that would be 16 negative 32 plus 16. You'd still get 0. So it works out both ways. Once you have your vertex, go find your x-intercept. Again, that would be where y equals 0. This is where I was about to go towards. So this is 0 equals x squared plus 8x plus 16. I try to factor just because that's what I try to do first. And when I do that, I see that two numbers that multiply to 16 and add to 8 would be 4 and 4. So I see that this would just be x plus 4 times x plus 4. You can check it. 4 times 4 is 16. 4x plus 4x is 8x. So when I then take these factors and I set them equal to 0, I only need to do one of them since they're both the same. So I get x equals negative 4. So your x-intercept, I think it wants it as a coordinate on your homework, is negative 4 comma 0. So it ends up being the vertex and the x-intercept. So that only gives us 1 point. So we do need to figure out maybe a y-intercept. So let's try to find a y-intercept to give us another point, which is x equals 0. You can plug it into either one of these. It doesn't really matter. Again, I kind of default to the starting, but it might be easier, just as easy as to do the other one. So this is 10 times negative 2 plus 36, not times. That gives you negative 20 plus 36, which would give you 16. So I get a y-intercept of 0, 16. So when I do my graph here, I'm actually going to go by twos. So this would be 2, 4, 6, 8, 10, 12, 14, 16. And then this would be 2, 4. So I have a vertex at, let's do a different color so you can see it, at negative 4, comma 0. And then, oh, hold on. Let's try that again. Negative 4 would be this way. So this right here would be my vertex and my x-intercept. And then this is my y-intercept. And if I went over 2, 4, and then up 16, I can go over 2, 4, up 16. So this coordinate right here would be 2, 4, 6, 8, 16. There you go. Now I have a symmetrical graph, give or take. All right. So let's kind of switch gears here to some different type of things you might see. Make sure y'all can see that. All right, perfect. All right, so I'm going to look at number 20. Number 20 says for each of the following parabolic parabolic graphs, tongue twister, find a formula for the corresponding quadratic function and use the formula to determine the coordinates of the parabola's vertex. So part A, we have to find a formula. So basically this means a equation for the corresponding quadratic function, and then use the formula to determine the coordinates of the parabola's vertex. So notice I am not given any vertex, because if we did, then we could instantly have our h and k, and then we could plug it into the formulas to find out what our answers are. All right. So make sure show you all the correct way, not one that's in my head. All right. So best process to this is we are given two x-intercepts. One at, oh, this is going by halves. Oh, that would have been tricky. This is going to 1, comma 0, and this is negative 2, comma 0. So that means quadratic wise, I have a factors of x plus 2 and x minus 1. So if I was to set these equal to 0, this is where I would find it. Then I'm given this coordinate right here, which would be 0, comma, negative 2. You can call this like your x and your y. All right, so what we're going to do is we're going to form an equation. So this would be like f of x equals this guy times a random a. If you remember, we had a pattern like this. Like this. So by doing this, I can kind of figure out the pattern because the other way is ax squared plus bx plus c. So notice it's the same a, both a's equal each other. So what I'm going to do is to figure out this answer, I'm told that if I plug in 0 for x, my answer is negative 2. So I technically have an x and a y plus this, and I'm going to use that information to help me solve for my a. So this right here is going to become a negative 2 equals a times 0 plus 2 times 0 minus 1. So when we work this out, I get 2 times negative 1, which becomes negative 2a, and then I'll divide by negative 2. So come to find out, a equals 1. So when I'm building this equation, I now have an a value. So when I come back and I back substitute into this equation, I would get f of x equals 1 times x plus 2 times x minus 1. So in reality, I really don't need this square, or sorry, not the square, sorry, this 1. So I can just fold this out. So this would be x squared. That would be a negative x plus 2x minus 2, which will give me x squared plus x minus 2. So there is my equation right here. That's part A. Part B then tells me, well, now I need to go find the vertex. Well, to find the vertex, I start by finding my x, which again is negative b divided by 2a, which remember, this is your a, this is your b, this is your c. So a equals 1, b equals 1, and c equals negative 2. So I get negative 1 over 2 times 1, which is negative 1 half. Don't be scared of fractions. And then to find the y value, I need to plug in negative 1 half into the equation. So I get negative 1 half squared plus negative 1 half minus 2. That right there will give me a positive 1/4 minus 1 half minus 2. 1/4 minus a half is actually negative a fourth, and the negative a fourth minus 2. So negative a fourth minus 2 would give you negative 9/4. Because 2 would turn into 8/4. And so therefore negative 1 minus 8 is negative 9/4. So therefore my vertex for this guy is negative 1 half comma negative 9/4. Now we did the math, but we can check it. Roundabout, this is about where you're at. So that's negative 1 half. And then this would be negative 9/4. Now we could have probably eyeballed that, but it's always better to do the math other than just eyeballing it, because we could be wrong. It doesn't always land on a perfect little thing. All right, let me make sure I covered all those details. Okay, perfect. I don't quite know on the homework, but I think you could have kept it like this. But to find the vertex, you would need to go to this form here. So I don't know how specific they're going to be on the homework there. All right, let's look at another problem. All I have is, we're doing the same thing, just with different stuff. So let's look at 27. Our number 27 says, given the points graphed in each of the following figures, use quadratic regression to find and graph each quadratic function of best fit. Now, last time I went through all the steps with y'all to find the linear one, but to do the quadratic, it's best to use a calculator. So that's why I want to pull it out now, and then I'll also show you what you could have done as well on 3-2 for linear regression. But on that one, they just expect you to know how to do it by hand as well. All right, so let me get my calculator pulled up. And I'll be using a TI Inspire for this. The textbook actually has TI 84 directions. All right, so let me share screen, make sure y'all can see it, and y'all can, okay. All right, so this is what an Inspire looks like. Typically, you might see something like this at a home screen or something like that. If you don't, just hit the home or /on button to get to this screen. Where we're going to be at is going to be list and spreadsheets, which is a thing that looks like an Excel. Biggest thing you need to do is make sure you label. There should be like a little name tag here for y'all. But if not, at the very top, you're going to label it as X, and the B will be your Y. Just use the arrows or click using the mouse. And then we're going to type in those coordinates. So going back, looks like we had 1 comma, is it going by 1? Okay, 1 comma negative 1. So that's going to be a 1, negative 1. Next one looks to be like 2 comma negative 2. So 2 comma negative 2. Next one, it looks to be like 3 negative 2. So we'll do 3 negative 2. And then the last one looks to be like 1, 2, 3, 4 comma 5. A big thing here is once you type that last number, make sure you hit enter or arrow down. This will tell the calculator that you're done typing. If not, it'll not register that point. So when we go to the next step, you'll have some issues. All right, so now that I have this, I'm going to hit the house on button, and I'm going to go to what we call data and statistics, which is this bar graph looking thing. And I'll have something like this. So I want to use my mouse, and I want to go to the bottom. I want to make that my x-axis. You'll see the blue dots move. Go to the left, make that your y-axis. You'll see the blue dots move there as well. So you can see off of our graph versus their graph, it's similar. It's just kind of zoomed in for us. But that's pretty much what 27 would look like. Next steps, you can memorize the numbers or just read the options. But we're going to start with menu. We want to analyze this graph, so that would be number 4. We're trying to establish a quadratic regression line, so we'll hit 6. Oh, went too fast. All right, so let's do that again. Menu, analyze, regression. Did I forget to arrow out? X and Y. Let me just hit the numbers. Maybe I'm just going. I was hitting too fast on this button. All right, so hit 6 for regression, and then you want to show a quadratic, because that's what we're working on is quadratic regressions. In the previous lesson, you could have showed linear by doing the same process, but they wanted you to do this whole table thing. I'm going to be honest with you. As long as you write out the steps that you used for linear regressions like this, I'm good with that as well. But for the sake of your homework, that was the process they wanted you to go with. All right, so I'm going to show quadratic, and then there you go. So it gives you a quadratic. You can actually move that over so you can see it better. So that's going to be, let me write that down. So I'll have to keep going back and forth. All right, so I'm going to bounce back to here. Are we still screen sharing? All right, good. All right, so therefore, my equation would be f of x equals 2x squared minus 8.2x. You don't have to do the plus or minus. You can just say minus plus 5.5. All right, so we've established our equation. And so it says, given the points graphed in each of the following figures, use the quadratic regression to find the graph of each function of best fit. So that's pretty much all we had to do. So you can, this looks like a complicated question, but because of technology usage, it can become an easier question. So again, like I said, when it comes to that linear regression, once you do it at least one time through the homework on the test, unless it forces you to do that as well, I'm good using the regression line on your calculator to at least check your work. Always use the tools that we have. All right, so after this, it's just a whole bunch of word problems. So I'm going to do as many as I can before my next class begins. So here we go. So I'll clear all the things, go this way with it. All right, so the first one, and I did copy them. So this would be number 32, just because, as y'all have seen so far, my handwriting is not the best. So to write this all out would be a hassle. But then you're able to reference as well where to go. All right, so on 32, it says Cindy wants to construct 3 rectangular dog training arenas side by side as shown, using a total of 400 feet of fencing. What would be the overall length and width be in order to maximize the area of the 3 combined arenas? Hint, let X represent the width as shown and find an expression for the overall length in terms. All right, so basically we have 400 feet, and it's wanting us to find the overall length and width. That should be the overall length and width be in order to maximize the area of the 3 combined arenas. All right, so here we go. So we got basically 4 walls and then 2 walls, basically lengthwise. So you have 4 widths, 2 lengths. All right, and we have 400 feet. All right. One thing you'll learn about me, sometimes I have to think a little bit. I prepare, but I don't prepare fully. But I will definitely develop an answer. All right, so what we know is this all has to be an X. So there's at least 4X worth of fencing. And then there's 2 times as much as the length here. See, let's see. So Cindy wants to construct 3 rectangular dog training arenas side by side as shown using a total of 400 feet. What should the overall length? All right, so I can see that this right here would be 4, and then I would have leftover. So this right here would be like 400 minus 4x. And that would give me a total length here. But there's 2 of them. So if we call this y, we call this y. In terms, this would be 400 minus 4x. Then I have 2 of them, so I'd cut that in half. Would it just be easier to say that this would be 4x plus 2y equals 400. So a little bit of plus sign here. The only issue is I have 2 of them. I think I'm going to have to cut that in half. This is the one benefit that's nice about working through this with y'all. So you would have 4x's. You would take that away from 400, take that result and divide it by 2, because you need to cut that in half. So I would almost say that this would equal 200 minus 2x. So let's start with that. So that would be your total perimeter, and it would equal 400. To maximize a profit, we need a quadratic. So we need to know, you would need to know the area of each one of these. And the area, if we're saying this is 200 minus 2x, we divide that by 3, times x, you need each one of these little sections. Or do I want the total area with each one inside? Hmm. Oh, let me pause this real quick and I'll come back with an answer. All right. So to quickly go through this one, I was thinking way too hard. All right, so this is 400 minus 4x times the 4x. So if I take these two and I multiply it to find the maximum area, this would give me 1600x minus 16x squared. You write this in the correct order. And then find your x for your vertex. So that would be your maximum profit. So that would be negative b, which in this case is negative 1600, divided by 2a. So that'd be 2 times negative 16, which is negative 1600, divided by negative 32. When you do the math here, you get 50. So that means my width equals 50. The only issue is if you back substitute this in right here, you get 400 minus 4 times 50, which would be 400 minus 200, which gives you 200. But that would be for both of these lengths. So you just cut that part in half and then you get 100. So therefore the length, or what is it? Who we let x be? X represent the width. Yeah, and so then length would be 100. And then this is a word problem, so you always want to add in the units. All right, so try not to think too hard, but you just establish a length and a width, multiply that to get a quadratic, then use the formula to establish what that x value is, and then go back to the beginning to back substitute. And that's pretty much how every little word problem is. If I had more time, I'd do more. But if you need more help, let me know. Until next time, bye.